Change. We live in a world of constant change, and calculus is the study of change. So, in this example, we have something that's changing. We have an invasive species of water hyacinth that's spreading over the surface of a lake, and you can see that the area covered by this water hyacinth is changing over time, right? So, we have a table that tells us how many square feet of the lake were covered at various time periods. Okay, so we went out and we measured an initial area of 500 square feet, and then after each week we again went out and measured the area to see the uh, how the area that has been covered by this water hyacinth is changing over time. Okay, so our first task in this example is just to graph the function. Okay, so I have time on the horizontal axis. Time is in weeks, so might make a note of that. And then the area is in square feet. That's on the vertical axis. Okay, so we're just going to plot these points. So at t equals 0, we're at 500. After 1 week, we're at 700. At the end of the second week, we're at 980, so maybe about there. And then finally, the end of the third week, we were up to like 1,390, so nearly 1,400, so maybe about there. Okay, now I have to make an assumption about what's happening in between, right? Because I only have data at these discrete points in time. So I'm going to make an assumption that it's just kind of smoothly transitioning from one point to the next, right? It's not jumping around, right? It's not going, it's not doing that. We're just going to assume that there's a smooth transition between these points. So I'm just going to draw a smooth curve between these points, right? All right, so there's a graph. All right, let's see. So there's a graph. All right, now the second question here is asking how fast is the area covered by the water hyacinth changing? Okay, now that's a bit ambiguous, right? What does that mean? How fast? How fast is the area covered? This is math, so we would like to quantify that rate. And so, but if you look at, okay, so you can see that the area covered is changing over time. And I can see over the first week, we have an increase of 200 square feet. So I could say that on week 1, let's just write week 1, okay, we had a change in area. Change in area we can denote with a Greek letter delta. This triangle is a delta. So we read this as delta A. That's the change in the area over the change in time. Let me make that look a little better. It's supposed to look like a triangle. Right? So we have a change in area of 200 square feet over a 1 week change in time. Okay, so I could say that during that first week, the water hyacinth is the area covered by the water hyacinth is increasing at a rate of 200 square feet per week. Okay, now I could do the same thing for week 2, right? I could look at that week, what's happening that week. It looks a little different, right? We could still look at the change in area over the change in time, right? But in this case, we're going from 700 to 980. So that's an increase of 280 square feet, all right? So I'd have 280 again over a 1 week period. So that's 280 square feet per week that week, all right? So it's different. All right, I could also look at week 3, right? Look at the change in the area over the change in time. Okay, so that's a 1 week period. And in this case, if I look at that difference between 1,390 minus 980, I get 410. All right, so that's a big jump, right? We went to 410 square feet in a 1 week time period. So 410 square feet per week is the rate of change during that week. Okay, so you can see that the rate of change, rate at which the area is increasing, right, is changing over time. Now, I don't have to do it over these individual weeks. I could look at the whole 3 week period. So we could look at weeks 1 through 3 and look at look at the change in area over the change in time. Now, if we look at a 3-week period, boy, we're going from 500 to 1,390. So that's an increase of 890 square feet. But now this time it's over a 3-week period. So I had to divide by 3 to get the rate per week. Okay, so when I put that in my calculator, I get 296.7, if I round it off, square feet per week. Okay, so you can see there's no one answer to this question. How fast is the area covered by the water hyacinths changing? Right, the rate at which the water hyacinth is changing is also changing. Right, it's different depending on what time interval we choose. Okay, so that brings us to our first big idea in this section, which is average rate of change. Okay, so if we have one quantity, y, is a function of another quantity, x, right? That just means that as x changes, it's going to change y, right? And so if we have y as a function of x, then the average rate of change is just the change in y over the change in x. All right, now change in y over change in x is slope. So if the rate of change was linear, then we would have a constant. Or if our quantity was changing linearly, then we would have a constant rate of change. In this case, we don't have a constant rate of change. We have you can see that for the case of the water hyacinth, that the rate of change is also changing. So, but all we do to find the average rate of change is take the change in our y over our change in x, and then we get the average rate of change over that particular time period. Okay, but it changes. Sometimes the rate of change changes depending on what the time interval is. Okay, so average rate of change is if we have y as a function of x, it's essentially the slope of a line connecting those 2 points. It's rise over run. It's slope. So that's the first big idea, is average rate of change.